Okay, so now this is the time we're going to start for the second chapter or part of chapter 12. This gets into the heavy mathematics of the chapter. This is going to deal with 4 formulas with 4 different ways of studying what we call concentration. The first one is percent solute. And what a concentration is and what percent solute does is that it's a comparison of the amount of solute with the amount of either solute or solution, depending upon what the information is asking for. So we're going to begin with percent. So we use percents all the time, but the general population really doesn't understand why or what it even really means. I mean, they know 50% is half, but why is 50% half? Why do we use percents as a comparison in the first place? Why don't we just say half? Why do we have to say 50%? Well, that's a debate that's never really been solved. It's just a preference of how people describe it. So let's deal with the mathematics of this. And like I said, in the mathematics of this whole section here is comparing solute over solvent or solution or some variation thereof. Percent solute is dealing with a comparison of solute with the amount of solution. Now, solution is the combination of the solute and solvent together. And when we say amount, it's usually in grams. It could be liters, could be milliliters, but the 99% of the time we're talking about grams. So let's look at the word percent so we can understand where the formula is coming from and what we mean when we say percent. This is actually a compound word, per and cent. First, the word per refers to the operation of division. Like if you're saying 70 miles per hour is the speed of a car, it's 70 miles divided by 1 hour time, so miles per hour. The per, then, is combined with the cent, which has the same derivation as what cent is used in centimeter, centigram, centipede, kind of. But we know there's 100 cents in a dollar because the word cent is Latin for 100. In Roman days, a centurion was a member of a brigade of soldiers that contained exactly 100. Centurion, cent, 100. So, percent means you're going to compare with 100 or divided by 100 or multiplied by 100, whatever it is we're doing. But it's per 100. So, if something is 50%, it's 50 parts divided by 100. And as we know, 50 divided by 100 is 1/2. This is why 50% is 1/2. Now I'm sure a good portion of you knew that already, but if you didn't, congratulations, you now have been brought up to percent mathematics in grade school. Why do we use percents? Well, it's because 100 is a really easy number to think of. So break something down to 100 parts, and 50 of the parts have been was solute, then we know that the solute is 50% of the solution. Okay, so it's just a comparison thing. So since 50% means a half, then you know that half of the solution is the solute. And so to this day, we use percents all the time, particularly data-driven analyses such as political polls. Keep hearing, if you pay attention to the news, you keep hearing things about popularity polls, favorability polls, sales pitches, about how things are reduced by X number of percent, 70% is the example I use here. It's insanely low. Oh my gosh, come buy my stuff. I've cut prices by 70%. And most people go, well, that sounds like a lot. I don't know what it means, but oh yeah, sure. It helps to know what you're talking about. So 70% reduced means you chop it up in the price into 100 parts, and then you remove 70 of it, and whatever that value is left over, that's what you have to pay. It is a good deal, actually. You're right. It sounds like a good deal because it is a good deal. The percent solute in a solution is defined as the amount of solute divided by the solution times 100. Okay? So this is what we're looking at here. Percent solute equals grams of solute over grams of solution, or grams of solute divided by the sum of the grams of solutes plus the grams of solvents. And both of these then are multiplied by 100 to get that percent bet put on that. Okay, so this is going to give us some fraction, and we're going to change the fraction over percent by multiplying by the value of 100. So that's the formula that we're dealing with here. So, the formula then, percent solute equals mass of solute over mass of solution times 100, or mass of solute divided by mass of solute plus mass of solvent times 100, which is what I just wrote. This is because the solution is the sum of those two masses. Example, what is percent solute when 25 grams of sodium chloride is added to 60 grams of water? So let's look at that on the board. We have 25 grams of sodium chloride, and we have 60 grams of water. And the question is, what is the percent of the solute in the solution? So the formula for that will be percent is equal to 25 grams of solute. It's a solute because it's being dissolved in the water. That makes it the solute. Divided by the solution, which is the sum of 25.0 grams plus 60.0 grams. And I have percent here because I'm a dork. It's supposed to be grams. And then we're going to multiply that by 100. So your calculator, you're going to take 25.0 divided by, and you put that in parentheses, or I think you might be able to add 85 grams times 100, and we get a value of 29.4%. So 29.4% of the solution is going to have sodium chloride in it. So in other words, if we divided the solution into 100 little cubicles, 29.4 of the cubicles will contain salt and the rest will contain water if you can get them separated before they mix together. Another example. How would you prepare a 125 gram solution of 20% methanol? CH3OH, methanol. So now we're being asked how to figure out the number of grams of solute and the number of grams of solvents. So this is kind of a different little problem, but it's still basically the same idea. Okay? So we know that the total solution is 125 grams. We know that the percentage is 20.0. So all we have to do then is solve for the mass of the solutes. So let's do that real quick. So it's 20% is equal to X grams of methanol divided by 125 grams of solution times 100. We got numbers and we only have one variable, that's that right there, so this now becomes an algebra problem. Now, I will caution you on one thing here. We're going to eliminate the percent sign here just to perform the operation value because some people will have a handle putting 0.20 there and then dividing by 100. The dividing by 100 changes the percent to a decimal. So I'm just going to get rid of the decimal to alleviate any potential misconceptions of how the problem is done. So algebraically, we're dividing both sides by 100. Cancel that out. That gives 0.200 equals X over 125 grams. And then we're going to multiply both sides by 125 grams. That's supposed to be a point, not a 1. Got a really bad handwriting. I'm in too much of a hurry here. So 125 grams cancel out. You got 125 grams here that we're multiplying by. And 125 times 0.2 is what you have the calculator or do it in your head if you're so inclined. 25.0 grams of sodium chloride. So now we know how much salt we have, or not salt, sorry. We now do methanol. We now know how much methanol we have. So how do we figure out how much water? Well, we know that the total solution, which is equal to the mass of the CH3OH plus the mass of the water. So this is 125 grams equals 25.0 grams of this plus the mass of the H2O. Then we move this over by subtracting 25 to both sides. Cancels out. And the mass of the water is equal to 100 grams. So, about 25 grams of methanol plus 100 grams of water is our final answer. And that's how you do that. Your homework, or your practice problems rather, 42 and 44 on page 547. Good luck.